Hello class. In this lecture I will talk about paired difference and I will try to solve this problem. Uh, a sleep disorder specialist wants to test the effectiveness of a new drug that is reported to increase the number of hours of sleep patients get during the night. To do so, the specialist randomly selects 9 patients and records the number of hours of sleep each gets with and without the new drug. The results of the 2-night study are listed below. Using this data, find the 95% confidence interval for the true difference in hours of sleep between the patients using and not using the new drug. Let D is equal to hours of sleep with new drug minus hours of sleep without new drug. Assume that the hours of sleep are normally distributed for the population of patients before and after taking the new drug. So one of the important things in this is your D is new drug minus old drug. So that means if this is sample 1 and this is sample 2, so hours of sleep, so this will be our sample 1 and this will be our sample 2. So the first question is find the mean of the paired difference and round the answer to 2 decimals. So I will use calculation aids and try to solve this problem. So I will go to canvas page and then do go to modules and then calculation aids in module 0, download chapter 11 calculation aids, and then do enable editing. So this is a mean paired problem because they are pairing those populations by using the deviation D. So whenever they use this D, that means they are pairing it. So in this case I have to note down these numbers. So I have to copy these numbers. So I will go to our sheet and then we have sample 1 and we have sample 2 which we want to note down. So our sample 1 in this case is the second row. So I will use 5.1, 8.5, 7.2. So let's do 5.1, 5.1, this is 5.1, 8.5, so that's 8.5, and then the next one would be 7.2, I hope I'm copying these numbers rightly. Okay, 7.2, next 6.5 and 5.2. So 6.5 and 5.2. 6, this is 6.5 and then 5.2, and then 3.3, 3.8, 3.3 and 3.8, and then 6 and 4.1. Six and 4.1. So sample 2, so sample 2 is 4.3, 5.7, 4.3, 5.7, and then this should be 6.3, I think. Let me put this 6.3. So this is 6.3, 4.9 and 2.9, 4.9 and 2.9, and then 2.9, and then 1.8, 1.8, and then 4.6, 2.2, 4.6 and 2.2. So let's hope I key in these numbers rightly. And then our alpha is 95% confidence interval. That means alpha will be 1 minus 0.95, that is 0.05. So that is our alpha. So we have alpha 0.05 typed in. So this is 0.05 5. That's almost typed in, already typed in. So what is the first question? So the first question they are asking is find the mean of the paired difference. So the mean of the paired difference, so the mean of the paired difference would be 1.689. So this will be the answer. Let me use a different color. The answer would be 1.689. Find the critical value that should be used in constructing the confidence interval. So the critical value that will be used for, so all these are related to confidence interval. So it will be 2.306. So this will be 2.306. What is, find the standard deviation. So the standard deviation would be 0.6411. 95% confidence interval will be 1.19 and 2.18. So that would be 1.19 and 2. Let me cross check this. 2.18. So one of the things is, if you see these two numbers both are positive, that means this D, hours of sleep, minus hours of sleep with new drug minus hours of sleep without new drug will have a positive lower bound and positive upper bounds. So the lower worst case difference is 1.19 and the best difference is 2.18. Since both are positive, obviously this first number should be greater than the second number if it is positive. So that means we can conclude by looking at this that the new drug is giving more sleep compared to old drug. So new drug gives more sleep compared to old drug. So we'll do question 5, which is hypothesis testing. Is there sufficient evidence to conclude that the new drug increases the sleep that patients get during the night? So we can do the hypothesis testing by, the first step of the hypothesis is you have to write your define your hypothesis. So as they say, it is there sufficient evidence to conclude that the new drug uh, increases the sleep that patients get during the night? So if you define mu d as deviation, so if d is the deviation for the difference of these two, and mu d, if this is greater than 0, so sample 1 minus sample 2, so 5.1 minus 4.3, so you will be looking at the entire population. So this greater than 0 is our alternative hypothesis, and then mu d less than or equal to 0 is our uh, null hypothesis. So once you have this, you can go and to our sheet and look at your hypothesis test. What are we doing? So you have this, you have three cases, and you are looking at the H alternatives. So let me go and show you here. So H alternative, how does it look? Mu D greater than, or mu D less than, or mu D not equal to? So let's go to our hypothesis and look at our alternative. So this will be mu D greater than. So I will go here, and this will be my I will be using this case 1. Our test statistic is 7.90. Our critical value would be 1.85, and we reject null hypothesis. So when I'm saying reject null hypothesis, this is false. So less than or equal to 0 is false. That means inherently this is true. So that means we have more the more sleep. The new drug provides more sleep. So we have sufficient evidence to say that the new drug increases the sleep of the patient getting during the night. So again, if you wanted, so if you see the critical value which we had is T alpha, degree of freedom. So that is given as 1.86859, 1.859, and our test statistic value is 7.90. 7.90. So if you wanted to show these in a normal distribution curve, so this is how it looks. Mu D is equal to 0. So this curve represents H null. So our null hypothesis, mu D is less than or equal to 0. So you have something like this here, and this will be your critical value, which is this one, 1.859, and anything below this, null hypothesis is true. Do not reject H null, and then anything above this is reject above this point. So above this line, reject H null. So if you see your T stat is 7.90, it will be on the right side of the null of the 1.859. So that means you fall under reject H null region. So this becomes, so if I am rejecting this claim, this is false, and then this is true. So that's how you will be solving these problems. So this concludes my lecture on paired difference. Thank you.